What's up, scholars? Today we're talking about classifying polynomials, and we're going to talk about end behavior of polynomials. Classifying polynomials. First way we classify the polynomial is identifying its degree. And the degree of a polynomial is just its highest exponent. Highest exponent. So a constant has degree 0. Our highest exponent is 0 would be some just plain old number all by itself. -9, that's a constant. Linear highest exponent is 1, so that would be like x minus 4. Quadratic highest exponent is 2. We've been talking about quadratics for quite a long time. Got x squared plus 3x minus 1. Cubic highest exponent is 3. Quartic highest exponent is 4. And quintic highest exponent is 5. And then after that, we stop giving them fancy names. We cut it off at degree 5, the quintics. All right, so example number 1, what would this be? I'm pretty sure there was something in that hole, but we can't see what it is. So the highest exponent here is 3. So this must be a cubic. And here, the highest exponent is 5, so this must be a quintic. Quintic. And classify a polynomial by its degree and also its number of terms. We find the number of terms by putting something in standard form and then counting the number of terms. By putting in standard form, and then counting number of terms. Counting number of terms. Count the number of terms after it's in standard form. A monomial has 1 term. Mono meaning 1. A binomial has 2 terms. A trinomial has 3 terms. And then after that, we stop giving them fancy names and we just call them a polynomial with n terms. That'll have n numbers of terms. So for example, here we've got 3x cubed minus 8x plus 19 plus 12x to the 4th minus 7x cubed. Oh my gosh. That's not in standard form at all. Highest exponent should go first, so the x to the 4th should go first. This is 12x to the 4th. We have 2 cubes which we can combine. 3 minus 7 is going to be negative 4x cubed minus 8x plus 19. So this is now in standard form. Highest exponent is going first. This has 1, 2, 3, 4 terms. So this would be a polynomial with 4 terms. Polynomial with 4 terms. This sucker, put it in standard form first. Highest exponent should go first. So this will be negative 8x squared. We've got lots of x's we can combine. 6x and x is 7x plus 10x is 17x. So this only has 2 terms. So this is a binomial. Binomial. So we can classify a polynomial by its degree, number of terms, degree and number of terms. Fabulous. These 2 examples are going to be for you. These are you try examples. You try. Name this with degree and number of terms. Name it with degree and number of terms. Okay. Now we're going to talk about the general shape of polynomial functions. If something has a degree 0, it's a constant function. So it has a slope of 0. Constant function. Could be a horizontal line or it could be a vertical line. Something with degree 1, if we recall, that was something like f of x equaled x plus 4. Right? That's our degree 1 highest exponent here. This is a line. It either has a positive slope or it has a negative slope. Something with degree 2. An example would be 3x squared minus 17, something like that. We either have a parabola going up or a parabola going down, depending on our a term. If a is positive, it goes up. If a is negative, it goes down. Okay. So obviously, in both of these examples, I gave you the positive versions. So this equation would not work for the other two pictures we drew. This is positive slope, so it's going up. You would need a different equation to go down. This has an a value of positive 3, so that goes up. You would need a different equation for it to go down. But in general, degree 0s are horizontal or vertical lines. Degree 1s are slanted lines. Degree 2s are parabolas. Degree 3s are either going to look like that, or the flipped version going to look like this. Degree 4s going to look like a W, kind of, a wiggly W, or it would go down. And a degree 8, oh my goodness, what in the world? All right, I'm gonna tell you. A degree 8 would either look like this. Woo, 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 woo! Or it would be the upside down version of this. How many? I went down and then up and then down and then up and then down and then up and down and up. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, or I went up, down. 2, 3, 4, 5, 6, 7, 8. Okay. That's what a degree 8 polynomial would look like. We are most interested in what's happening at the ends of these functions. The ends of these functions. Where are the arrows going? Where are the arrows going? That's what we're going to summarize in the next little chart. But let's take a look for a second. If we have our even degrees, degree 2, degree 4, degree 8, the ends of the function, the arrows are either both going up, both going up, both going up, or they're both going down, both going down, both going down. If we have an odd degree function, either the left side is going down and the right side's going up, left side's going down, right side's going up, or flipped. Left side up, right side down, left side up, right side down. Like my Dia de los Muertos skull. Yep. Thank you, Sammy, so much for this. Yep. So degree 2s, 4s, 8s, every even degree, the ends of the polynomial are going to go in the same direction, either both up or both down. Even degrees, if we have a positive leading coefficient, the left side's going to go down, right side's going to go up. If we have a negative leading coefficient, the left side's going to go up, right side's going to go down. All right, let's put that into our chart. The chart is actually up on the next page. So we're talking about even degrees. If we have a positive leading coefficient, both ends of the polynomial are going to go up. If we have an even degree with a negative leading coefficient, both ends are going to go down. If we have an odd degree polynomial, the highest exponent is an odd number and a positive leading coefficient, the left side's going to go down, the right side's going to go up. If we have an odd degree polynomial with a negative leading coefficient, it's flipped. Right side goes up, left side goes down. All right, let's go back to the page before. Our acronym to remember this is called SLED, where S and L is sign of the leading coefficient, right? That's if we have a positive or negative leading coefficient. And then evenness evenness of the degree. So do we have an even function or an odd function? So let's look at example 1. We have, let's look at the degree first. That always sticks out to me. This is a degree 3. So this is an odd function because the degree is 3. Degree equals 3. 3 is an odd number. And our leading coefficient is positive. Positive. Leading coefficient is 14. That's a positive number. So an odd positive function, let's look at our chart. Odd positive. Odd over here, positive leading coefficient. Left side's going to go down, right side's going to go up. Left side's going to go down, right side is going to go up. How about here? We have a, oh my goodness, it's still an even function, but this is not in standard form. Oh, not in standard form. This should be 5x to the 4th plus 3x squared minus 17x. This is a degree 4, which makes it an even function. Has a degree 4. Ooh, that's a crazy looking D. There we go. DG, degree, is 4. That's an even number. And the sign of the leading coefficient. That's a good thing we put in standard form. Otherwise, we might have done something goofy here. 5 is a positive number, so this is a positive even function. Let's look at our chart. What's a positive even function look like? Even function, positive leading coefficient. Both sides are going to go up. Both ends are going to go up. 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 All right. Let's lookity-look over here. This is in standard form. Great. This is an odd function because it's a degree 5. It's a quintic. We have a negative number in front of the highest exponent. So this must be a negative odd function. Look at our chart. Negative and odd. Odd's over here. Negative leading coefficient. Left side's going to go up. Right side's going to go down. Gonna look like that. This, again, not in standard form. Blasphemous. Negative 2x to the 8th plus 3x to the 7th plus 12. This is now an even function, because 8 is an even number with a negative leading coefficient. We have an even negative, which is the only combo we haven't done yet. Look at our chart. Even function, negative leading coefficient, both ends go down. Both ends go down. All right, hot diggity dog. Let's go on to the next page. We are going to sketch a graph of the function using the correct end behavior. We're in standard form. Great, this is a cubic, so that means it is odd. It's got a negative leading coefficient, so this is odd. And negative, odd, negative. Left side's going to go up, right side's going to go down. It's a cubic. So that means we went down, up, down, 3 directions, kind of. 3 directions. 1, 2, 3. Down, up, down. It's going to look like down, up, down. That's our negative cubic. This next one, example 3, it's in standard form. Great, highest exponent is 6, which makes that an even function. Leading coefficient, there's nothing here, so it's a 1, but that's a positive number. All right, cool. So we have an even positive, which means both ends are going to go up. We'll have 6 directions. We're going to go down, up, that's 2, down, that's 3, up, that's 4, down, that's 5, up, that's 6. Okay, something like that. 1, 2, 3, 4, 5, 6. Great, and you try. That means that's for you to try. Fabulous, you got this. Totally got this. And finally, Write a possible polynomial equation given its graph. Okay, we're missing some arrows on the graph, so I'm going to add some arrows here. This has a left side going down, a right side going up, left side down, right side up. So that must have made it left side down, right side up, an odd degree, positive leading coefficient. So this must be odd and positive. So a possible, oh wait, also how many directions do I have? 1 going up, 2 going down, 3 going up, 4 going down, 5 going up. So this must be a quintic. Quintic. Because we had 5 directions. We went up, down, up, down, up. That's 5 directions. So we need a quintic with a positive leading coefficient. F of x equals, we do a super simple one here. We could call it x to the 5th. That's a quintic. It's got a positive leading coefficient. You could add some junk to it if you wanted to at the end. But what I'm really looking for is, can you tell me how many directions it's got and what the sign of leading coefficient is going to be. Example number 5. Again, there's no arrows. Let's put some arrows on that sucker. We got both ends going down. Both ends going down makes this an even function with a negative leading coefficient. So this would be even with a negative leading coefficient. How many directions do I have? Up, down, up, down. 4 directions. So this is a quartic. I need a negative leading coefficient. So an example would be negative 2x to the 4th plus, I can add some change, x squared minus 17. I'm just making up some things. So if I wanted to be more precise, that right there would be my y-intercept, which is clearly a positive number. So that should be a positive 17. Anyway, I'm most interested in, can you give me the correct sign of the leading coefficient and the correct degree based on the changes of direction here. Y finalmente, this is a U-try. This is a U-try. I feel like this looks like something else we did somewhere, maybe, possibly. Oh! Don't want to give too much away. We'll do a little recap, though. We talked about classifying polynomials by their degree, which is their highest exponent. You can also classify polynomials by their number of terms. You were going to do that right here. Classify the polynomial by its degree and number of terms. We also sketched out shapes of polynomials. Degree 0, boring, straight lines, horizontal or vertical. Degree 1, starting to get more interesting. That's a slanted line. Degree 2, near and dear to our hearts. That's a parabola. Degree 3, that's a cubic. Degree 4, that's a quartic. Degree 8 doesn't even have a fancy name. It would just be a polynomial of degree 8. But it does have 8 directions. Down, up, down, up, down, up, down, up. 1, 2, 3, 4, 5, 6, 7, 8. That's what a degree 8 is going to look like. And then we made our handy-dandy little chart here to help us figure out what the ends of a function are going to look like. What's going on in the infinities where those arrows happen. Even functions, either both sides are going up or both sides are going down, depending on the sign of the leading coefficient. Odd functions, one side goes up, one side goes down, depends who is who, based on the sign of the leading coefficient. All right, scholars, that's it. I love you so much. I will see you next time. Keep on that hustle.